Hey everyone, welcome to Code Harmony. In this video, we will be discussing about LeetCode Problem ID 2894, divisible and non-divisible sums differences. In this video, I am going to discuss about the brute force to the highly optimized approach, and it is based out on math. I have already prepared a video on this in which I have discussed the approach where I will be solving it in linear time and a slightly optimized version. But this problem is also be done from order of n to order of n divided by m. I will tell you what are these numbers, and in constant time. So to discuss about the constant time, I'm going to create a new video and keeping this as a beginner friendly. And if you are just starting with this video, I will attach the link in the description below. Just have a look on that once. Now let's try to understand the problem statement. Here we are given two positive integers n and m and define two integers as follows. Okay, these two integers we have to define nums1. What is nums1? Nums1 is the sum of all the integers in the range 1 to n, both inclusively, that are not divisible by m. And nums2 is the sum of all the integers in the range which are divisible by m. And in the end, what I have to return is return this value, nums1 minus nums2. So this is my problem statement. Let's understand with the help of an example. In this example, value of n is 10 and value of m is 3. It means what I have to return is sum of all the numbers which are not divisible by 3. Not divisible by 3 are 1, 2, 4, 5, 7, 8, 9. Sum of all of these numbers are 37. And then subtract sum of all the numbers which are divisible by 3. Those are 3 numbers, 3, 6, 9, which are 18 in if we take the sum. So 37 minus 18, 37 minus 18, which is 19. 19 is going to be my answer. So this is something we have to do. And here is the time to discuss about the approaches. And the first approach, that is like a brute force that can come to our mind, is like we can run a loop from I equal to 1 to I less than equal to n, and we can capture nums1 and we can capture nums2, and in the end we can return the difference. Nums1, how we can capture? Which is not divisible by m. If I divisible modulus with m is not equal to 0, that will come to nums1, otherwise it will come to nums2, and in the end we can return nums1 minus nums2. That is going to be my answer. But here in this case, my solution time complexity is going till order of n time. Till order of n time. But as I've also shared that in the video attached to the description below, I have discussed an approach where I am able to do it in a better time. See, what I'm concerned about is I have a range 1 to n. For that I am given this n variable, and apart from that I am also given a number m. What I have to do is finding the sum of all the integers which are not divisible by m, and finding the sum of all the integers which are divisible by m. If integers are divisible by m, so that is definitely going to start with m. Then what is the next one? Next one is 2m, third one is 3m, fourth one is 4m, right? M, then plus m, plus m, plus m, plus m, until it is less than equal to n. So this is the range. This is the range, and if you try to analyze, this is an AP, arithmetic progression. The delta is same for every two number. Okay. So what I have analyzed so far is the range is from 1 to n, and what I need to find out is nums1 and nums2. And what is nums2? Sum of all the numbers which are divisible by m. If I have to find sum of all the numbers which are divisible by m in this range, what I can do? I don't have to run the whole loop of n size. What I can do is I can start with m and directly jump to the 2m and directly jump to 3m and directly jump to 4m and so on until it is less than equal to m, right? So I will run a loop while, let me take a temporary variable. Temporary variable is starting with m, and while this temporary variable is less than equal to n, what I will do is nums2 plus equal to this temporary variable, and this temporary variable plus equal to m is the same thing, plus equal to m. The delta is m here in this case, and here this loop will take time, which is n divided by m time. So this was the approach that I used in that video. And here, why I did this? I did this because after this I will be able to find out nums2. Nums2 is like sum of every multiple of m within this range. So this is the sum of every multiple within this range, and this sum I will be able to figure out in order of n plus m. But what is the use of that? See, use of that is just tell me the formula of all the numbers from 1 to n. That is n into n plus 1 divided by 2. This formula we can apply in order of one time, and this formula is equal to nums1 plus nums2. Nums1 plus nums2. We have this value in order of one time, and we get this nums2 in order of n divided by m time. If we have these two values, we will be able to get this nums1 as well. So we have nums2, we have this value, we will be able to get nums1, and if we have nums1 and nums2, we can get our answer by returning the nums1 minus nums2. So this approach we did in order of n plus n divided by m time. And here it is the time for the optimized approach. We are given n and we are given m. N signifies the range from 1 to n, and m is something we are concerned about the numbers which are divisible by m. We also need to initialize two variables, nums1 and nums2. Nums2 is the sum of all the numbers where I is divisible by m and the others are into the nums1. Okay, let's say, see, first number within this range is going to be m definitely. And what is the next number? Next number is like m plus m. If I take from 1 to 10 and take multiple of 3, so those are 3, then 3 plus 3, then 3 plus 3 plus 3, 3 into 2, 3 into 3, 3. 3 into 1, 3 into 2, 3 into 3. M into 1, M into 2, M into 3, M into 4 until M into K. So it will look something like this. And here if I see or try to analyze, m is common. If m is common, I can do something like this: 1 plus 2 plus 3 plus 4 and plus till k, right? And what are these numbers? These numbers are the one which are divisible by m. And here, what is the sum of first k natural number? First k natural number are k into k plus 1 divided by 2 into m. Okay, what is this value? This value is nums2. So nums2 we are able to figure out. And what is nums1 plus nums2? N into n plus 1 divided by 2. What is this value? This value is equal to nums1 plus nums2. Because if I choose any number between this range 1 to n, that number is either non-divisible by m or divisible by m. If it is non-divisible by m, it's in nums1. Divisible by m, it is in nums2. Okay, the sum is equal to this. Okay, this is something I have written here, and this nums2 value I have captured. What is this value? M plus 2m plus 3m plus till km. And if I just extract out the m, I'm left with sum of first k natural numbers. Sum of first k natural numbers, and the formula is this. Now we have nums2 and this one, but what we have to figure out is, we have to figure out nums1 minus nums2. Let's try to form this into that way. Nums1 minus nums2. To balance out to the above statement, I have to add nums2 2 times nums2. This value is something we have to figure out. And if I take this value on one side and other values on the second side, I am left with this n into n plus 1 divided by 2, taking this value and taking this nums2 value, minus 2 into nums2. This is the formula, and what this value is equal to, this value is equal to nums1 minus nums2. Okay, so this portion on the right side, and this one is here, and this one is coming here. Okay, now my formula is a bit completed. I know the value of nums2. What is this nums2? This nums2 is equal to m into k plus 1 by 2. Let me write it here. N into n plus 1 divided by 2 minus, if I write it here, 2 to 2 will get cancelled out. M into k plus 1 by 2. M into k plus 1 by 2. By 2 is cancelled out by that 2. So this is the formula. And this is something which is equal to my answer. Here in this case, if I just try to see if I am able to do it or not, this n is given, this m is given. What is this k? K, what is k? K is how many multiples are there. How many multiples of m are there in n? If I try to show you by example, let's say my range is from 1 to 10. How many multiples of 3 are there in this range? 10 divided by 3, which is 3. If I take in the integer form, okay, got it? So how many multiples are there of m in this range? N divided by m. So this k signifies the number of multiples. So this number of multiples is equal to n divided by m. But keeping in mind that it is an integer. Now our program is complete. I have k, I have n, and I have m. What is my function? So let's say this is the function, taking n, taking m as input and returning integer as our value. First of all, I am finding what is the value of k. How many multiples are there? K is equal to n divided by m. Got it. And now I have all the sufficient variables. I have n, I have m, and I have k. I can directly write return n into n plus 1 divided by 2 minus m into k plus 1 k. K into k plus 1 m this is the formula. So this is our complete code for this approach. And here what I am doing is just one operation, just one expression which is constant time. Just one formula we have derived, and we will be able to do it in a constant time now. Order of one time and order of one space for this problem. Now let's code this approach. Now let's see if our formula is working fine or not. Here what I am doing is I am capturing k, which is n divided by m, and then I am writing my formula. In my formula, n into n plus 1 divided by 2. So this is the first part of the formula, and subtracting m into k plus 1, n into n plus 1 divided by 2 minus m into k plus 1 into k. Let's see if it is working fine or not. Sample test cases are working fine. I am submitting the problem. It got submitted successfully. I hope you understood this approach. In case you have any doubt, you can comment down below. Thank you guys. Bye bye.